Hello, my name is Beth Dixon, and this is part one of it's not part one, it's part two of a video based on Vicki Borlaug's PowerPoint presentation on a binomial distribution, and it is a summary, and I had thought I was going to be able to go through all of this example in one video, but alas, I did not get through all of it. So let's look at the examples to set up in case you did not watch part one. A fair die is made for a children's game, and each side of the die has an animal on it. The animals are a shark, a polar bear, a pig, a mouse, a goose, and a lobster. And we're actually picking up on part E, but I want to go back and look at part D first. And in part D, we were asked to find the mean, variance, and standard deviation. Now, I'm not going to go back over those, but I wanted to go back over what the numbers were so that we would have those as we worked on part E. We found the mean to be 80 times 1/6, or 13.3333. And we found the standard deviation to be the square root of 80 times 1/6 times 5/6, or 3.3333. And you may need to watch part one to get the details on that, but I did want to refresh our memory on what those numbers were. Now we're ready to go on to part E. If the die is rolled 80 times, would it be ordinary or unusual to roll a lobster 21 times? Ms. Borlaug used two different solutions here, and solution one is using the z-values. Remember, the z-value is the number of standard deviations from the mean. And we want to determine whether it's ordinary or unusual to roll a lobster 21 times. And a data value will be considered unusual if its z-value is less than -2 standard deviations or greater than 2 standard deviations. And our number line illustrates this much better than any words I could say. We consider anything within 2 standard deviations in either direction ordinary. Anything more than 2 positive 2 standard deviations or more than 2 negative standard deviations away from the mean, so more than 2 standard deviations away from the mean, is unusual. Anything greater than 2 or less than -2 would be considered unusual. Our formula for z is z equals x minus the mean over the standard deviation. And down here at the bottom, we know that our binomial has a mean of 13.3333, a variance of 11.1111, and a standard deviation of 3.3333. So, since we're dealing with a lobster would it be unusual to roll a lobster 21 times? 21 is our x, minus the mean of 13.3333 divided by the standard deviation of 3.3333. That should then give us a z-score of 2.30. Where does that fall on our number line? Well, that is greater than the 2 standard deviations. It is more than 2 standard deviations above the mean. Therefore, it is unusual. It falls in the unusual range. Conclusion, it's unusual. We can also use the raw data values. Is it ordinary or unusual to roll a lobster 21 times? Again, if it's more than 2 standard deviations away from the mean, it's unusual. Again, we want to mark our number line, and in the center we will place the mean. Our mean is 13.3333, and we'll place that there in the center. Our standard deviation is 3.3333, so that means each jump jumps by 3.3333. That means as we move in the positive direction, we will add 3.3333. And I'm getting tongue-tied. The first time we do that, we get 16.6666. The next time we get 19.9999. And 19.9999 is 2 standard deviations above the mean. We can do the same thing going below the mean, and we can also see that 3 standard deviations is 23.3332. Oh, and Miss Borlaug went as far as to do 4 standard deviation jumps, which is 26.6665. Now she also goes to the left by subtracting 3.3333 and gets 10, subtracting another 3.3333 and gets 6.6667, and another subtraction of our standard deviation to get 3.3334, and another one to get 0.0001. And that becomes our raw data. Where does 21 fall on this number line? Well, 21 again still falls in the unusual range, and therefore our conclusion is unusual, and that is the way we can do this using our raw data. Thank you for watching this video. I do have some other videos that do binomial distribution problems, and they will be helpful as well. And as always, Walter State students are welcome to stop by and see me in the math lab in MBSS 222. Thank you.